There's another technique for solving systems of equations. And again, you've probably seen this before with linear examples, and we're just going to review it with a linear example here, and then we're going to move on and apply this same technique to nonlinear examples. Our textbooks calls this the addition method. It's also known as the elimination method. So depending on what textbook and what teacher you had in previous classes, you might be used to calling this the addition method or the elimination method. They're the same thing. Okay. And again, what I'm going to do is work out this example over here, and as we do it, I'm going to record the steps. Okay. So with this example, notice both of these equations have the same types of terms. There's some x's, there's some y's, and there are some numbers. Okay. But right now, they're written in slightly different form, because in this first one, the x's and y's are on the left, but in the second equation, only the x's are on the left. The first thing I'm going to do is rearrange them so that they're both in the same form and I can line up like terms. And I think the easiest way to do that is just to add this y over. So I'm going to keep that first equation just exactly as it is. 2x minus 4y equals negative 6. I'm going to add over that y to say 4x plus y equals positive 6. Okay, so the first step is to write both equations in the same form, lining up like terms. Now, that's not always going to work. In the example that we just did, we had x squared plus y squared equals 2, and y equals the square root of x. I didn't have like terms. This one, substitution, was a much better method. But elimination or addition can be useful if your equations have the same types of terms. Now, the basic idea here is that I'm going to take one of these equations and I'm basically going to add them together, meaning that I'm going to add their left sides together. And since their left sides are equal to the right sides, I can add their right sides together, and that will be true as, and those two things will be equal. But before I do that, I want to make sure that that's going to be useful. I want to make sure that it's going to eliminate one of my variables. If I were to add the equations now, let's just see what I get. 6x minus 3y equals 0. I just have another equation that has two variables in it. My goal is to eliminate one of the variables. Okay. So while this is legal, I haven't done anything wrong, I haven't gotten any closer to the answer. What I want before I add the equations together is I want to have either the opposite number of x's or the opposite number of y's. So if I don't already have the opposite number of a certain type of term, I'm going to have to manipulate the equation. So what I could do is I think I'm going to take this second equation and I'm going to just multiply it by 4. That way I would get 16x plus 4y equals 24. So each term on both sides got multiplied by 4. Now if I keep this one the same, notice I've got the opposite number of y's in those two equations. So now when I add them, the y's will drop out. The other thing I could have done, since 4 is a multiple of 2, I could have multiplied the first equation through by a negative 2, so that I'd have 4x's here and a negative 4x's here. Okay. I chose instead to multiply the second equation through by 4, and that's fine. Sometimes you might have to change both equations. In this case, we were able to get to the opposite number of y's, just changing one of the equations. Okay. Now, I'm going to add. So, I'm going to have 18x, the y's cancel out, equals, oh, that's lovely, 18. Okay. So, step 2 is to, if necessary, multiply one or both equations by appropriate numbers to get the opposite number of one of the variable terms in the two equations. Now, since we're working with nonlinear equations, it might not necessarily be the opposite number of y's. I might have a case where I'm getting the opposite number of y squareds, because y squareds are the types of terms that I have. But I'm going to try to get to the opposite number. Okay. And then step 3, I can add, I'm just going to say sort of informally add the equations. Now, I'm not really adding equations. What I'm doing is I'm adding the left sides and I'm adding the right sides and I'm saying they're equal. So sum of left sides equals the sum of the right sides. Okay, and what I'm hoping is that I have eliminated one of the variables. So my goal in doing step 3 is to get to something like this where I have an equation in one variable. So the result should be an equation in one variable. So that's very similar to when we do substitution. We start with 2 equations and 2 variables. Our technique is to get it down to one equation in one variable. Of course, once we have that, we can solve it. Here I would just divide both sides by 18, and so I would get that x is equal to 1. Now I'm running out of space here, so I'll just continue. Step 4, we'll start up here at the top, solve the result of step 3. And then again, we're not done because we've got one of the 2 variables. I need to know both of them. So once I know x, I can plug back into any of the equations that have 2 variables, and I can then solve for y. Okay. I don't think it matters. I'm just going to use this bottom one here. So 4x becomes 4 times 1 equals 6 minus y. That's 4 equals 6 minus y. Negative 2 equals negative y. So 2 equals y. Okay. So we've got x is 1, y is 2, or if I wanted to give that as an ordered pair, it would be 1, 2. So step 5 is to plug into any equation with both variables and solve for the remaining variable. Basically, once I know one of the 2 variables, it's just like substitution. You plug in, you get the other one, and then don't forget to state the answer clearly. Answer or answers, because there could be more than one point that's going to be a solution for us. Okay. And again, that's important because you've got x values and you've got y values, and if they're scattered all over different pages or different parts of the page, it can be hard to see what goes with what. Make sure you're pairing them up so that you're giving me clearly what the ordered pair is that is a solution, or what the ordered pairs are if there's more than one solution.